Hello friends, colleagues and other people. In this machine learning and computer vision tutorial, we explain how to correctly install Meta's Segment Anything Model 2 or SAM2 in Python and Windows, and how to write an object detection and tracking script in Python. Over here you can see a brief demonstration of what you will learn in this video tutorial and a brief demonstration of the SAM2 algorithm. The video on the right hand side represents an input to our algorithm. Our goal is to track the coyote in this video. So how do we do that? Well, we first freeze one of the frames and then we identify 2 points that are on the body of the coyote. For example, we can identify this point and we take their coordinates. This video and these 2 points are actually the input for the SAM2 algorithm, and SAM2 algorithm performs magic. Namely, it is able to clearly track the coyote, it is able to segment the coyote and to recognize the background and the coyote, and also to apply the mask. And this is just a simple demonstration. You can do way more than this. For example, you can change the color of the coyote, you can, for example, add some effects, and you can do all sorts of things. But before we start with explanation and coding, we first need to explain what are the software and hardware prerequisites that you need to have in order to successfully implement and run the Python code. First of all, you need to have a relatively new GPU. We have NVIDIA 3090 GPU with 24 GB of RAM. We also tried NVIDIA 2060 Super with 8 GB RAM, and the computation is at least 4 to 5 times slower than computation performed by using NVIDIA 3090. Then, you have to install NVIDIA CUDA Toolkit from the official website. Both CUDA Toolkit and PyTorch should be installed separately. To install CUDA Toolkit, you need to go to this website. I created a separate video tutorial explaining how to install NVIDIA CUDA Toolkit in the Windows operating system. Also, you have to make sure that CUDA home environment variable is added to the Windows environment variables. How to check that? Well, over here you can simply search for environment system variables, then you can click over here, and then you should see over here CUDA home. Double click here, and the value should be the path to the CUDA installation folder. In my case, I'm having version 12.5 CUDA, and here's the complete path. So click on OK, and let's close this. Now, here, there might be some compatibility issues with Visual Studio C++ compiler, and I will explain that later on. Then, you need to install Microsoft Visual Studio C++ 2022 Community Edition. This edition comes with a C++ compiler that you will need to compile some files. Keep in mind that this is not VS Code. VS Code is an editor, but Microsoft Visual Studio C++ is more than that. To download Visual Studio 2022 Community Edition, you need to go to this website. Also, we will need this program to make sure that PyTorch will have the necessary DLL files. We notice that in normal Python virtual environments, there are errors if Visual Studio C++ compiler files are not installed. Also, there are known compatibility issues between Visual Studio 17.10.5 and CUDA versions 11.8 and 12.1, and probably with some other CUDA versions. The solution to this problem is to either downgrade Visual Studio 17.10.5 to some older version, or install the new version of CUDA 12.5. Trial and error is required here. In our case, we have seen that Visual Studio 17.10.5 works okay with CUDA 12.5, and this is our solution. Notice that CUDA 12.5 is the newest version in July 2024, and if you're watching this after that, there might be even newer version. So here you have to match Microsoft Visual Studio Community Edition with the proper version of CUDA. I will explain that even later on. Then you need to install Anaconda. We need an Conda since we will install SAM2 by using Conda virtual environments. Consequently, download and install an Conda. I created a video tutorial how to do that. Link will be provided in the description below. Then you need to install FFmpeg command line audio video tool for extracting image frames from videos. We created a tutorial on how to do that, and here is a link to that tutorial that will also be given in the description below. The download page for FFmpeg is over here. You need to follow the instruction in the video tutorial, and you have to make sure that FFmpeg is in the Windows path, and you can easily check that by simply opening a terminal and typing FFmpeg. And as the output you should see that actually FFmpeg is installed. That is, you should see something like this. This means that you have properly installed FFmpeg and that you have it in your Windows path. Optionally, you can also install Visual Studio Code for editing Python files. However, you can also use some other editor to edit and execute Python files. In this video tutorial, we will be using VS Code. Again, I created a video tutorial on how to install VS Code. The link is provided in the description below. To summarize, we are using CUDA Toolkit version 12.5 and we are using Microsoft Visual Studio 2022 Community Edition version 17.10.5. Okay, so let's start. The first step is to clone or to download SAM2 repository and other files. To do that, let's open a command prompt. So click on Start and search for command prompt. And over here, we need to go to an appropriate folder. Usually, I download repositories and other files and I place them inside of my codes folder, but not exactly inside of the codes. I will actually create a new folder over here and I will call this folder SAM2. Then I will navigate to the SAM2 folder, and in this folder we need to call the git clone command. So let's do that. To clone the remote repository, we need to execute this command. So let's copy this command and let's paste it over here. Over here we are actually cloning the git repository at this address. And let's press enter. And over here you need to be patient. This will take maybe... it's very quick. Good. Perfect. So let's go to the new folder. First of all, inside of our SAM2 folder, we will see another folder. So let's navigate to that folder. And this is the base folder of SAM2. The next step is to download the necessary model checkpoints. Model checkpoints contain the weights, network structures, and all other things necessary to run the model. For that purpose, let's go to our project folder. That is, let's go to Codes, to SAM2, Segment Anything. And over here you will see this folder called Checkpoints. Open this folder and then you will see this script. Let's open this script. Since I'm on the Windows machine, I was not able to run this script. This script will actually download the necessary checkpoints. That is, it will download these files that you can see over here. Now, since we cannot download it by running this script, we need to download it manually. So how to do that? Well, by inspecting this file, we can see this. First of all, you can see that this is a base URL. And on top of this URL path, we need to add the file that we want to download. And that's precisely what we will do. So let's do that. So what you need to do, you need to combine this thing with this thing, this thing, this thing, etc. Okay, so over here, I already did that. So this is the complete path for the particular checkpoints. For example, for this tiny model, this should be the complete path. So let's learn how to download them. To download them, you need to go to your browser and then you need to type this. So I will copy this, go here, paste, and if I press enter, you will see that the checkpoint is downloaded. And here it is. Okay, so we need to do that for all other files. Okay, if basically it's difficult for you to write this path, you can simply, as I said, copy this part over here, then add the corresponding checkpoints. Okay, so let's do it. So this was the first file. Let's do the second file. Okay, you'll see it's a bigger file. Then let's do the third file. And this one is even bigger. And finally, let's do the last file. Here it is. And now be patient, since this will take some time to download. Okay. Once these files are downloaded, go to the Downloads folder and simply copy them. Next, go to your codes, SAM2, segment anything 2, and go to the checkpoints folder and paste the files over here. That is, all the files should be inside of this folder. This is very important. The next step is to create Conda virtual environment, to install packages, and to build everything. To create a Conda virtual environment, we cannot use an ordinary command prompt. We need to use Anaconda command prompt. So click over here and search for Anaconda prompt and open Anaconda prompt. Now let me change the size of this screen so you can see what I'm typing. Immediately you will see that we are in base Anaconda environment. Okay, so let's navigate to our project folder. I will go to codes, SAM2, then I will go to segment anything 2, and here we are. In this folder, we need to create our virtual environment. To do that, we need to execute this. That is, we need to type Conda create name environment1. Okay, so be patient over here. This will take some time. Click on yes, and here it is. The next step is to activate our environment. So type Conda activate environment1. Okay. Then let's start with the installation of packages. Note that if you open the file setup.py, and let's see that file, this is a very important file. This file is located over here. This file will explain you what are the required packages. Now, I had several issues with following this approach, namely, as you see later on, we can automatically run this file as well as something else. This file will actually try to download and install these packages, and in addition, it will also do this, and this is very important. This will actually compile some files by using CUDA. And you can see over here what's happening. Here you are compiling extra compiler arguments. However, if you try to do that, you will see several errors, and I was not able to do it. Instead of doing that, I will show you the procedure that I follow. That is, I will not manually run this file. I will first do something else. So let's do that. First of all, I will close this, and let's go back to our terminal. What you need to do actually is first to verify that CUDA home is properly set in the Windows environment. So let's double check this once more. All that we did is search for environment variables, then search for, click here, and you can see that CUDA home is over here. Double click here to see the complete path. Click on OK, and click OK. So this is the first step. Next, let's run this command to make sure that we have proper versions of CUDA. As you can see, this is the version of CUDA. Now over here in this manual, it should be like this, just to correct this. Then let's make sure another thing that we can see from this terminal, this environment variable. So let's type CUDA echo and CUDA. It should be actually like this, echo CUDA home, and let's see this thing, and we can see that we can actually see this environment variable inside of this terminal. Perfect. Then, before you do anything, install this thing. Note if you run installation of Python packages from Conda, you cannot just write conda pip install. You need to do this. You need to conda install conda forge and then set up tools. So let's run this and be patient over here. This will take some time. Sometimes I notice in this terminal you need to press some key, space or enter because it sometimes doesn't update itself. So you'll see, for example, this thing is doing something, doing something forever. However, it's not doing. It's just not being updated. You just need to press a key. Okay, the next step is to install PyTorch. To install PyTorch, you first of all need to go to this website and you need to find this table. This is a selection table that will enable you to choose the proper settings. So let's click on Stable, Windows, Conda, and let's choose this CUDA version over here. And click over here. Notice over here that this CUDA version for PyTorch is the different CUDA version from the one I installed. I installed 12.5 as a toolkit. However, this doesn't create an issue. So let's copy this, paste this, and let's run this. And this will take some time, since PyTorch is a really big program and it contains a lot of dependencies, as you can see over here. Here are the dependencies that you need to install. Basically, by installing PyTorch, you install NumPy, you install a lot of things. So let's click on yes, and you will see the progress over here. This will take probably 5 minutes even or so, depending of course on how fast is your computer and how fast is your internet connection. So let's be patient to see the main screen. Okay, in my case it took quite a short time. This is mainly because a lot of these packages are already cached and they are kind of already somehow on a disk, so you're just plugging them from a disk. In your case, you will see the complete installation progress, and I saw that the first time I installed PyTorch. So I often uninstall, however, somehow some part of the installation remains in a cache, such that next time you try to install, the installation process is much faster. Okay, the next step is to actually install matplotlib. So let's do this. And here you need to be patient. Again, this might take some time. Click on yes. And that's it. Okay. And the final step is actually to run this. This is very important step. Now, in the background, this is actually running the setup.py file. However, we have already installed a lot of packages, so the setup file will actually skip these packages and it will automatically go to the compilation. That is, it will compile CUDA, and this is the most critical step. And let's hope that everything will be fine. So let's press enter and let's see. Okay, so far so good, and this is the most critical part. And after some time you will see this successfully install SAM2 1.0, and you can see it over here. This error message is actually not relevant. It doesn't come from the compilation of CUDA, it comes from something else. And you can simply ignore it. Okay, this was the most important step. If you pass this step, this means that everything is fine right now. The next step is to add a video file to our project and to extract frames from our video. First of all, let's make sure that we are in this base folder, and let's create another folder called video. We will store our video and extract the frames from the video in that folder. However, first of all, we need to locate our video. In my case, I will use actually this video over here from the beginning of the tutorial. However, you can use some other video. The most important thing that you should see a moving object in your video. Then I will simply copy this video file to my folder. So it is codes SAM2 segment anything 2, and here it is. Actually not, yes, here. I need to find the video folder, here it is, and I will paste it over here. Good. Now if you go back to the terminal and if you type this, and if you go to the video folder, you should see the video file. Good. Next, I will extract the frames from this video by running this command. To run this command, you need to have ffmpeg. I actually created a separate video tutorial explaining how to install ffmpeg. A link to that tutorial is given in the description below. So what will happen over here, we will take our video called video 1 and we will extract JPG images that are numbered from 0 with an increased counter. So let's run this and let's see what will happen. And now if we type this, we should see our images. Here they are. Perfect. To see these images just as a double check, let's go again to the video folder and here are the images. So this is the first frame. This is, for example, frame 34, etc. What is interesting to observe is that this video is made with 30 frames per second, and consequently the video length is around 11 seconds, so that's why you have around 341 frames, and this is super important. Okay, so let's go back here and let's continue. The next step is actually to create an output folder. So let's create an output folder by going here, and I will create a folder called output. Let's go to that folder, and of course this folder will be empty. What's the purpose of this folder? Well, in this folder we will store the generated images. Namely, the SAM2 model will take the input images, will do processing, detect the object, create a mask, and then create the output images that will be saved frame by frame in this folder. And once we have them in this folder, we will be able to again create a new video out of these images. Okay, this is very important step. The next step is to actually write our code and to generate the output images. So let's learn how to do that. The next step is to create our file. First of all, I will go to the base folder, and then in this folder I will start VS Code. I can do that by typing code dot. Of course, you can use some other editor to edit Python files. However, I like VS Code. Next, let me create a new file. To do that, click on File, New File, and I'm going to call the file as test1.py. Then you can see that VS Code automatically recognizes the folder, and I will save it here. And over here, I'm going to paste the content of the file that I wrote previously. I wrote this file by first downloading a file from the official GitHub page of SAM2, and after that I made significant modifications. This was necessary since the file from the official GitHub page was written keeping in mind Linux machines. However, I'm having a Windows machine and I had to make significant modifications. Also, I modified the file such that I can save images and such that later on I can create a video out of saved images. Okay, so what's the purpose of this file? This file will actually read frames from this folder, it will process them, and it will produce the output images that will detect the coyote. This is the whole idea. And let's explain this file line by line. First of all, these are the standard imports that are necessary to run the code. Over here, I imported input output. Then, Over here, we set bfloat16 for the entire code. That is, we set the data type for the entire code. This is a standard piece of code that will turn on tfloat32 for Ampere GPUs, for more advanced GPUs. Here are the model checkpoints, and I listed all the model checkpoints from my checkpoints folder. So let's find the checkpoints folder and all the files we downloaded, and I simply listed them over here. Here they are. Then, how do you choose your model? Well, over here you need to specify the path to the corresponding model. Notice one very important thing over here. Namely, let's look into the Windows path. So let's copy this and let's compare with what is written over here. Okay, so compare the path given over here and this path in Python. The difference is that we need to add double backslash to create a Python path out of Windows path, and always keep in mind this. In addition to these model points, we need additional configuration files, and here are the additional configuration files. Namely, for example, if you've chosen this model, we have to choose the additional, or better to say the corresponding configuration file, and here it is. For example, for this model, the corresponding configuration file is this one, etc. So where are the configuration files? They're actually stored over here in this folder, and this is also very important. However, you don't need to specify a path to that folder because somehow internally this code will know. Okay, over here we create the predictor object, we specify the configuration file, and we specify the checkpoint file. Here's our mask function. This function will accept a few things, that is, it will accept some geometrical properties and it will generate a mask in our image. For example, if you detect a coyote, you want to mask a coyote on that image. This is a very important function. This is a function for showing points. Here it is. You can choose the colors, you can choose other things. Let me now scroll over here such that you can see the complete function. And over here we need to specify the path to our frames, that is to our images. Our images are actually stored in this folder, in the video folder. Here they are. And consequently over here we need to specify the path. As you can see over here, here is the path. This path is created by taking the Windows path and by adding double backslash. And that's it. So the code will read the images from this file automatically. This piece of code will scan the JPG frames names in this directory. This is very important. Then you will sort frame names. And over here is the most important part of the code, in my opinion. Here we will show a desired frame. So why do we want to show a desired frame? This is mainly because we want to show the first frame or second frame or some other frame in order to be able to detect the object. So what I will do right now, I will run this code and I will run until here, and then I will automatically break the code. I will just run the code to read the first image, and then I will manually see where my coyote is located in order to specify 1 or 2 points on the coyote body. This is a very important step. Okay, so let's save this file. Remember that the line is 88. We are going to continue explaining after this line. So let's now go back over here, expand this, and let's learn how to run this file. So, to run this file, first press Ctrl-Shift-P, and over here search for Python, select interpreter. And this is very important. You have to make sure that you're running Python executable from your environment. And you need to select this, and then let's run the code. Most likely we will see an error over here, and I will explain how to fix that error if we see it. So let's run the file. ignore this first part over here and let's see what will happen. Good. No errors so far. We will see later on. Okay, so this is our frame 0. And over here, if I scroll or if I move my mouse on this image, you can see the XY coordinates over here. So watch over here what's happening. Right? I can see an XY. Now, what you need to do, you need to put your mouse on the coyote and find 2 points on the coyote body. For example, this point over here, you can see the coordinates in the top right corner, and the second point, and write this point somewhere. That is, write the X and Y coordinates. And this is very important. Now I will close this, and the code will automatically run. It will do something else. However, I will explain that later on in the video. So I will press Ctrl C to cancel this. Okay, so this was the very important thing. Now, over here, we set the inference state. That is, we set the initial state or initialize the state. We specify the video path, and we reset the state of our predictor. Over here, we specify the frame index. That is the frame index we want to interact with. And over here, we gave a unique identifier to each object we interact with. That is, we will call our coyote as object 1. Of course, you can track many objects on your image. However, I'm tracking only a single object, and I will denote my coyote as object ID 1. Over here, we need to enter the point coordinates. We identify 2 points, and over here, I enter them. So you can see XY, XY, and they're stored as rows of a NumPy array. Of course, if you want to have better detection, you will basically select 3-4 points or something like that. Here, we create another things, labels. This is standard. And over here, we add our point. That is, we add the point we just defined. We specify the inference state that we just defined over here. We specify the frame index is 0. We specify the object ID is 1, and this is very important, we specify the points and we specify the labels. This is how we put the labels. That's it. Okay, then the results will be shown on the current frame. We create a figure, we create a title, we create image show, then we show the points and we show the mask and we plot everything. That's it. Next, we propagate through the video and collect the result in a dictionary. So what will happen over here, the algorithm will propagate through the video. It will actually detect the coyote as the coyote moves over different frames, and it will store the results in a dictionary. And finally, we can render segmentation results every few frames. Over here, I'm rendering the result every frame. So what do I do over here? I define a new figure, and over here I iterate over the generated video, that is over the generated frame, with this step, that is with the step of this frame stride, and I simply create my image. I open the original image, first of all, from my folder, then I add the mask to this image, and what do I do over here? I simply save the figure in the output folder, and you can see how I do that. If you now go over here, you will see that the images will be saved in this folder, and this is very important. Okay, so let's run this code and let's see if we will see an error, and I will explain how to fix that error if we see it. So let's run the code and let's hope that everything will be fine. Okay, I will simply close this window since I already detected these 2 points over here, and just to remind you, I entered them over here. So for example, if I go back, one of the point is here, you can see the coordinate, another point is here, and you can see their coordinates over here. So I will simply just continue my code. I will close this, I will press enter to continue, and now the frames are being loaded. That is, we are loading everything. Here we are. We are loading everything, and here we have to be patient. This will take some time. Around 30 seconds actually. So let's wait. We have time to wait. Few more seconds, let's be patient. You can see that we have 342 frames over here. And let's see what will happen now. Okay, so this is the error that I want to show you. Here you can see that there are no available kernel, aborting execution. So let's learn how to fix this problem. You might not see this problem for some other GPU or for some other configurations. To fix this problem, you need to go over here to this folder, to SAM2. Then you need to click on modeling. Then you need to click on SAM, and then you need to edit this file called transformer. So I will click over here. And of course, the transformer file can also be found over here. So here's the path. Just in case you didn't see what I did, here is the path, and you need to edit this file. And over here, we need to say a few things. To fix this problem, over here you need to add these 3 lines. Use flash attention false, mat kernel on true, and all GPU true. That's it. Save this file. Let's go back to our test file and let's run it again. Click over here and let's run the file. Don't forget to save this transformer file. And over here again, let's close this. Let's press enter to continue. And again, the frames will be loaded once more, so be patient. Okay, good, we passed this part over here, and let's look into our coyote. Here it is. Here is our beautiful coyote. You can see how it's masked, and you also have some artifact over here, but it doesn't matter since the color probably of this branch is similar to coyote. However, this will be filtered, so it will not be creating issues. You can improve this by adding few additional points over here. However, I'm not going to do that to make this video as short as possible. Okay, good. So let's close this and let's press enter to continue. And now we are propagating in the video. So what's happening right now, we are actually detecting coyote frame by frame. And that's it. You can see that this is super fast. And let's bring up my task manager to see memory consumption. You can see on GPU what's happening. I'm actually not consuming a lot of memory, and you can see the basically how the GPU processor is being used. Not so much, since this is basically passive thing. And let's continue. Now something is happening. Okay, so what's happening right now, we are actually saving the files. So let's see where are the files. They're in the output, and here they are being created. Okay, so this is our first image, this is our second image, this is our third image, this is our 7th image, etc. Perfect. So we are now generating images. Congratulations, we were able to run the code. Now, before I conclude this video tutorial, I need to explain how to combine all the images in a single video, and I will explain that in the sequel, after I have probably maybe 100 images. So be patient over here and wait for 100 images to be generated. After some time, you can see that approximately 55 or 56 or around 60 images are being generated, and here they are. Okay, next let's learn how to create a video out of these images. Of course, let the code to run until the end. However, I want to show you this so I can conclude this video tutorial. So first of all, let's go to the terminal and let's go to the folder called output. And in this folder, let's run this command to create the video. The video name will be output mp4. This 30 over here means frames per rate. And over here, I will also select the frame rate to be 30. This is very important. These are the input file formats. This is how we format them. This is similar to C++. Namely, what happens over here is that you have files that are S0, S1, S2. So how to encode that using regular expressions? Well, we do it like this. S is the letter, and we have this %D. This is a standard C format for integers, and the format of the file is PNG. That is, by writing this, we kind of encoded how the input files are encoded, right? This is very important, and this is the frame rate. Then this is the codec, and this is some additional parameter, and this is the output file. Okay, so let's run this, and this should actually be relatively quick. So let's just go here, let's just move and press enter, and you'll see the output, and here it is. Now, where is the output file? Here it is. Unfortunately, I cannot open this file by using Windows Media Player. I need another one. So I open usually these files by using the VLC Media Player. So install and download VLC Media Player, and you will be able to run the file. And here is the thing. It's approximately 2 seconds. 1, 2, 1, 2. Perfect. Okay, that's all for today. Thanks for watching.